Okay, so we're going to take a look at circuit diagrams for parallel circuits as well as equations for parallel circuits. So when we are drawing diagrams of parallel circuits, the key thing to remember is branching. So for example, here I've drawn a simple circuit with one resistor. This isn't really classified as parallel or series. There's just one resistor. Probably you'd say series just because there are no branches. But what we're going to do next is add on another resistor and another one. Okay, and so here I have three resistors, and it's kind of like they're making parallel lines with each other. Okay, but the key to notice about this circuit is that all of the current is going to be passing through the battery. But then when we reach this point right here, we call that a node. A node is just where we have the wire kind of branch off. We have two directions for current to go. Current can flow through the first resistor or can continue moving on. So some of the current is going to flow through the first resistor. The rest of the current is going to keep going. That current is going to get to the next junction and it's going to branch again. So some of that current is going to go through the second resistor and the rest of the current is going to go through the third resistor. Okay, until we come back here and my second and third resistor branches combine. So now we get the current that went through the second and the third resistor continues on, and then we join up again. Now the current that went through the second and the third resistor joins up with the current that went through the first resistor, and then all of the current comes back through the battery. So once again, what we see in parallel is having these nodes or these junctions where current splits. So think of like a fork in the road. Or like an exit on the expressway, okay, where you can kind of turn off or keep going, okay? And so the current makes a choice. Some of the current goes through here, some of the current keeps going. So all of the current goes through one of these resistors rather than all of the current going through every single resistor like what happens in series. Now I'm going to show you guys another way to draw this exact same kind of circuit. So if we've got three resistors that are all in parallel, I can also draw them this way. Okay, so give you just one moment. Okay, so here's kind of my one resistor, but then I can have a wire, actually I should say three wires coming off of the same spot. So in this one, we see the exact same thing. Our current, all of the current leaves the battery, and then we get to this node, and here all of the current branches at the same location, as opposed to here where the current kind of branched multiple times. So the current divvies itself up between the first, second, and third resistor, and then all of that current comes back together, and then all of the current comes back through the battery. Okay, so here are the things to keep in mind in parallel. So in parallel, we're going to have multiple loops. So if you see multiple loops for current or multiple paths, that tells you that you are in parallel. So another way to look at this is saying that we have more than one path for our current. Okay, and so again, how this differs from series is instead of all of the current going through every single resistor, any given charge only flows through one of these resistors. Some of the current goes through the first resistor, some of the current goes through the second resistor, the rest of the current goes through the third, and then they all rejoin up back here. So what that means is that we add up the current going through each resistor. That gets us the total current that's traveling through the battery. And whatever voltage the battery is, we have that exact same amount of voltage that's pushing the charges across each resistor. So the voltage drops across each resistor are all equal to the voltage of the battery. Okay, so now let's take a look at the equations. So for our equations in parallel, we're still going to use Ohm's law. So we kind of have two variations of Ohm's law, if you will. So the first one is for the entire circuit. I'm going to put a B here standing for battery. Some people use a T meaning total. Either way is perfectly fine. It means the exact same thing. So here I have the battery voltage is equal to the current traveling through the battery times the equivalent resistance. Okay, remember equivalent resistance is just what is the resistance of the whole circuit if we were going to treat it like it was just one giant resistor. And the other variation of Ohm's law is for each individual resistor. So for example, voltage across resistor 1 equals the current passing through resistor 1 times the resistance of resistor 1. Okay, so now let's take a look at the specifics for parallel circuits, because so far this looks just the same as with series circuits. Okay, so like I mentioned when we were talking about the circuit diagrams, the current that is passing through the battery is equal to the sum of the current going through each resistor. So if I add up the current through resistor 1 plus the current through resistor 2 plus through resistor 3 and so on, that's going to get me my total, because this total splits up and then travels through the different resistors and then all comes back together again. Okay, and because it does that, our voltage for the battery is the same amount of voltage that pushes some of the current through resistor 1, same voltage that pushes some of the current through resistor 2, same voltage that pushes the rest of the current through resistor 3, okay, or you keep going if you have more resistors in parallel. Okay, so far not too bad. So some things you should notice: Ohm's law looks exactly the same whether we are in series or in parallel, because we've got Ohm's law for the entire circuit and Ohm's law for each individual resistor. And then the next two are flip-flopped from series. Remember, series, the current was the same and we added up the voltages. In parallel, we add up the current and the voltages are the same. So that one you just kind of have to memorize. Here is the tricky one. So the hard one is equivalent resistance. So in parallel, the way we figure that out is the inverse of the equivalent resistance equals the inverse of resistor 1 plus the inverse of resistor 2 plus the inverse of resistor 3, and so on and so forth. Okay, and I will show you an example problem in another video where you can see how to set up this equation and how we're actually going to do this in the calculator, because it is a little tricky. It's not too bad, just plugging and chugging the math in the calculator, but it's easy to make mistakes. So pay very close attention when you're trying to calculate this one.